This can be our lecture video for November 18th and 19th. Go ahead and get out your notes. Let's start with a couple of warm-up problems. Number 1, which of the following is a solution to the inequality 5x plus 3 is greater than 38? Answer choices are 5, 6, 7, or 8. So one idea is we could just start plugging them all in for x and then computing the left-hand side and seeing if we get a true inequality. But that might take a little while. So a better idea is let's take that inequality there and simplify it so we're not doing the same steps each and every time. We don't need to add 3 to this side every single time if we subtract 3 from both sides at the beginning. And we get 5x is greater than 35. We don't have to multiply by 5 each time if we just divide both sides by 5. And we get that x is greater than 7. Now, this is much easier to just plug these numbers all into that and see which ones work. Is 5 greater than 7? Nope. Is 6 greater than 7? Nope. Is 7 greater than 7? This is like our boundary case, but because it doesn't have that or equal to, this one also doesn't work. 8 is the only one that works. 8 is the only one that is indeed greater than 7. All right, next one. There are 40 students and 12 teachers driving to Six Flags. Each car holds 5 people. What's the least amount of cars needed? All right, so what we need is a variable here. So we'll say x equals number of cars. All right, now we can start setting up our equation. So 40 students and 12 teachers. Well, let's just off to the side do 40 plus 12 to get that's 52 people are driving to Six Flags. Each car holds 5 people. So if I take the number of cars and multiply it by 5, so 5x, I'll get the number of people that are riding in the cars. All right, what's the least amount of cars needed? So we want this amount here to be greater than the 52 people that are coming. All right, now let's divide both sides by 5. We get that x must be greater than, this is 10.4. So we need 10.4 cars, but we need to round that up. We must round up. And I'll let you think about that. If we only brought 10 cars, we'd only be able to transport 50 people. 2 people would be left behind. We can't bring 0.4 of a car. So the least number of cars we can bring is 11. So 11 cars is the least amount. And that's our final answer. We'd be able to transport up to 55 people, which is more than the 52 we have. All right, which is good because we've got 12 teachers, so there'll be a driver for each car. All right, goal for today is to be able to write inequalities for word problems and solve them. Why are we doing this? Well, one of the biggest reasons I can think of is that in order to stay within a budget, you want to always spend less than you make. It's probably the most important inequality of being financially sound, is to always just spend less than you make. If you spend exactly what you make, then you'll never have any savings. So that's why we use an inequality there. All right, I wanted to go through this vocab again real quick. Let's write out the correct interpretation of these sentences using a variable. We'll pick x. So at least 5. All right, so 5 is acceptable if you say at least 5, but in general you want more than 5 if 5 is the least. So this needs to be a greater than or equal to 5. At most 5, that's just the opposite of this. So 5 is again acceptable, but we want it to generally stay less than it if we say at most 5. So less than or equal to. More than 5, that's just a greater than symbol. Less than, we can use a less than symbol. All right, here's two new ones. No more than 5. All right, so if I want no more than 5, then 5 needs to be the maximum. I want x to be less than or equal to 5. 5 is acceptable. If I say no more than 5, then you can give 5. You just can't go above. No less than, so this one will flip around. X is greater than or equal to 5. All right, we can be equal to 5. We just can't go less than it, so we must be greater than it. And there we go. All right. So let's copy down the important problem values from this word problem here. Antara has $500 in a savings account at the beginning of the summer. She wants to have at least $200 in the account by the end of the summer. She withdraws $25 each week for food, clothes, and movie tickets. Write an inequality to represent the situation. Let X be the number of weeks. We want to figure out basically how many weeks Antara can keep this up, withdrawing $25 each week without dipping below her threshold of 200. All right, so as we break down this word problem, it's always good to figure out what number we're starting with. So Antara has $500 in a saving account at the beginning of the summer. So it says at the beginning, so we're going to start with 500. She wants to have at least 200. So when we see that at least, we can write the inequality. So we want the amount she has to always be greater than or equal to 200. If she ends with exactly 200, that's okay, because she says at least. 200 is acceptable. So the inequality is going to be, write it with green, match the color scheme here, it's going to be greater than or equal to. All right, at least 200, so she wants to end with 200. All right, she withdraws, so the operation there, because she's withdrawing, let's match the color scheme here, it's got to be subtraction. And then the unknown, she's withdrawing 25 each week. What we don't know is the number of weeks. So we'll say 25x. $25 for each week. We just don't know how many weeks. All right, let's put this all together into an inequality. So we started with 500. We're subtracting 25x. And we want that amount there to be greater than or equal to 200. All right, let's solve this. I'm going to go ahead and subtract 500 from both sides. Get negative 25x is greater than or equal to negative 300. I think I was going to use this as my number line, but I need the space. All right, divide both sides by negative 25. Now be careful here, we just divided by a negative, so we need to flip the direction of our inequality. X is less than or equal to, I think that's 12. All right, and now we can graph it on a number line. Put 12 right in the middle, closed dot, arrow going to the left. All right, so now to answer the question, I guess there's not really a question. It's more just represent the situation, but we can still put this all together into a sentence. she can keep this up for a max of 12 weeks. She can keep withdrawing $25 each week for a maximum of 12 weeks and stay above her $200 threshold. All right, so in a word problem, how do you know which number has a variable attached and which one stands alone? So for variable attached, we're looking for words like per or every or for each. Those are our signal words that we have a coefficient. For which one stands alone, we could have words like starts with or ends with. So if we're being told a starting or an ending value, that number is not going to change. Right? That is just the number at the start, and then, the value could change based off of, some other term, but the amount that you started with, that's fixed. All right. So a couple more word problems. So Elisa won 40 lollipops playing basketball at the school fair. She gave 2 to every student in her math class. She has at least 7 lollipops left. Write an inequality to represent the situation. Be sure to define your variable. So we'll say, I'll define it up here. L equals number of, well, we know how many she has left. Actually, let's not pick L, because we know everything about the lollipops. What we don't know is about the students. So she gave 2 to every student in her math class, so S equals the number of students. All right, so write an inequality. So she starts with 40 lollipops. Then she's going to give away 2 for every student in her class, which we don't know, so 2S. She has at least 7 lollipops left. So this amount here is how many she has left. This is greater than or equal to 7. Now solve the inequality to find the max number of students in her class. 40 minus 2s is greater than or equal to 7. Let's move our constant to the other side by subtracting 40 from both sides. Negative 2s is greater than or equal to negative 33. Divide both sides by negative 2. And we get that s is less than or equal to, let me do that one on the calculator, 16.5. But we can't have less than, or we can't have half of a student. So because this is a less than, we have to go down to 16. There are a max of 16 students in her class. And actually, once we figure out that 16.5, if you're not sure that you face your inequality the right direction, you could just check 16 and 17 and see which one still makes sense. If I plug in 17, then she would give away a total of 34 lollipops and only have 6 left, which is not at least 7. With only 16 students, she would give away 32 and she'd have 8 left, which is at least 7. So that's how we know we need to round down to 16. All right, last one. More than 450 students went on a field trip. 10 buses were filled and 5 more students traveled in a car. Write inequality to represent the situation. Be sure to define your variable. So what do we not know? Well, what we don't know is the number of people on each bus. So we'll say B equals number on each bus. But we know that there were 10 buses, so we can say 10B. And then 5 more students traveled in cars, so plus 5 additional. We know that this amount here is more than 450. All right, I'll subtract 5 from both sides. We get 10B is greater than 445. Divide both sides by 10. And we get the B equals 44.5. All right, but we can't we can't put half of a student on a bus, so we know that the minimum is 45 students per bus. It could be more than that. There could be 50 on each bus. All that we know is that more than 450 students went on this field trip. All right, I'll embed a few more questions here. We'll call that good for this video. Have a good rest of your day.